present the next speaker, Bertrand Loison. Is it correctly pronounced? Yeah. So Bertrand will talk about data science and official statistics. Is it a myth or a reality? And he's actually leading the data science working group at the Swiss Federal Statistical Office. And this group aims to implement data science processes and algorithms in the current statistical production. So Bertrand, let us know what official statistics can do for us.
Okay, thank you very much. It's a great pleasure to be here this afternoon. Thank you for the nice introduction. My presentation will try to show a little bit the path that official statistician has chosen, not just in Switzerland, but also internationally, to address this topic. That means that the UN, but also the OECD and the IMF and such kind of organization. And at the end, I will explain a little bit more what we are doing in Switzerland. Nevertheless, we need to understand the global concept. And maybe the first question we should answer is why are official statisticians interested in data science? And the answer is, I took an example not from Switzerland, but from UK. 4 or 5 years ago, the parliament in UK decided to give a mandate to evaluate if the NSI, the FSO if you want, but in UK, is ready to evaluate, to measure this new society that is happening due to the digital transformation. And I don't have time now to explain all the details, but it was quite an interesting result, and that was one example why official statisticians think that it's something that we need to dig deeper in this topic. Okay. I move very quickly. As you can see, that's a recent history of, you don't have to read everything, it's not necessary. You see here on the slide the recent history of official statistics. And every bubbles were more or less a major change in the way we deal with data for many different reasons. And currently we are addressing the three, I will explain that, the three blue bubbles since more or less 10 years. And the first bubble is the globalization, and globalization of the economy. Generally speaking, we don't produce the goods and the services the same way it was the case 30 years ago. The second is we need evidence-based decision-making systems. And the third thing is that we are facing a new eco-data system worldwide that has been created during the last 10 years, more or less. And we are not, as you can see, the OECD is also addressing this topic. The UN gave a strong advice to every country to dig deeper in this topic of big data science. It was 2015, if I can remember correctly. Voila, that's more or less the why, okay? And now I will try to explain the steps that we did. The first thing that we need to understand is what is big data and how can we introduce big data in the current statistical production. Because currently, our statistics are based on surveys. They are also based on administrative data since more or less 10 years, 15 years. And what is big data for us? That's just new data sources. We try to identify a little bit what are the key difference, in which topics we need to invest, really, if you want to deal with this new kind of data. And you can see on my slides the 4 red-marked topics were really for interest for us. The first one, the statistical method. The second one, the coverage. And the timeliness was a big issue for these new data sources. And if you know a little bit this field, you know that the word big data is not new, that the key purpose of big data is to deal with data management, IT infrastructure, and we are statisticians, so we are not really interested in that, but on the layer of that means the analytics at the end of the day. And we try also to identify a little bit, okay, these big data, because the word big data doesn't mean really something very concrete. And for us, we strongly believe that big data, you can have a huge amount of data, but if the veracity, that means the data pedigree, is not clearly defined and identifiable, that's really complicated to generate new insight that within the quality that we need, and you need to find also this data need to bring value to your business. That doesn't, more data doesn't mean automatically better insight. Okay. At the international level, we define these three kinds of. We try to identify the big data from the point of view of the producer, and we define three categories. The first one is there are human-generated data. That means you can read, for example, social media. The second one are more structured data. This is process-mediated data, if you want. You have credit cards, e-commerce. And the last one is the Internet of Things, with primarily these information are coming from sensors. It's quite important for us to have this classification, but because we strongly think that you can address all these kind of data the same way in the production process. Okay, now we needed to answer another very important topic, and that's that. Why should we invest money and time in big data? What are the business reason? Why should we do that? And we found at the international level three main reasons to invest. The first one, we believe that we can answer new questions and we can produce new indicators. That's a really important thing. The second thing is to bridge the time lag of official statistics and maybe also to make some forecasting. And the last one is just to innovate with the current statistical production, just by having new data. So it's quite an important step to answer the reason why should we invest money and time. Okay, now I will move a little bit more quickly about is Internet of Things. That was another thing we needed to address. I'm personally convinced that Internet of Things will change a lot of things regarding the data. According to SARS, we have between 50 to 80 billions of connected devices by 2025. That's not nothing, okay? And even if the name IoT is not new, as you can see that. And the question was what that means really, IoT, Internet of Things. And at the end of the day, Internet of Things, the things are data, okay? And you can apply exactly the same concept for the qualification for use. That means veracity. If you don't ensure the veracity of and the value, it's quite useless. Now, a much more tricky part, and we try to explain what these approach. We have two approaches of analytics, if you want. And in order to address that, we invest a lot of time in complementary analytics method. That means algorithm and models coming from machine learning, deep learning. And we published in 2017 a strategy called Data Innovation Strategy. And since since 2017, we run 5 pilot projects. I don't speak about the IT infrastructure. I think it's not the topic for this afternoon. And in order to explain, I don't have to explain the different kind of analytics. I think you're expert, you know about what I'm talking about. But we have to admit that official statisticians until now are majority focus on descriptive statistics. And if you want to move to another kind of analytics, we maybe also need to rethink a little bit these search for causality. The reason, and now I try to explain what we did. The traditional way of working for statisticians is the deductive reasoning. That means you start from an idea, you collect data for statistical purpose, you have, and after that you run some statistical tests, and that's a classic deductive reasoning. We are using primary data, what we call primary data, but it's really important to understand this deductive reasoning. This is a classical one. if you want to move in this field for data science, is another approach from the conceptual point of view. You start not from the idea or from the theory, but from the data. And it's an explorative, predictive, on inductive, predictive analytics, inductive reasoning. And according to Turkey, which is well known in this field, he mentioned in 1980, it's not new, huh? He said if you want to have accurate results, you should combine both approaches. And I think that's quite an important thing. Because try to take an example. You want to measure employment in the country. Okay, you start with a theory that defines employment. You collect data. You apply. You have a data set. You apply your statistical test, and if they are positive, you make the assumption that you measure the employment. If you start from here, you apply some machine learning, deep learning algorithm. You have this pattern. You try to find pattern, and we need to cope that with literature and theory. That's what we are trying to do because we can afford, as official statisticians, to have black boxes. So simple as that. We need to be able to explain the results that we found. Okay, very quickly, analytics of things, also a concept we are currently dealing with. Analytics of things is only the layer over the IoT, and that leads to a new way of producing statistics, and we'll spend just 1 minute about that. The classical way here, you collect the data, you run the analytics as a traditional way. With the analytics of things, we will have to rethink the way we run the analytic, and we will have to put the computation out, probably. That means to move the data quality framework to the data, to the sensor. And we are not finished with this work. It's not easy to do, but still we're investing. Very quickly, that's our traditional production process, very close with deductive reasoning. If you want to deal with data science, we need to review our statistical production. That means for a pilot project, we worked with CRISP-DM, which is not bad, but currently we are trying to implement this development cycle and deployment cycle in our current production. Now, if you're interested to know more about that, I published with my colleague Diego Conan an article in the Statistical Journal of the iOS. I think it's worth it to spend 5 minutes to read the article about this topic. Okay, the conclusion, official statistics and data science is not a myth, it's a reality at the UN level, and it's accessible, free of charge. You can see on which kind of data we are working on. Mobile phone data, scanner data, social media data, and you can find really very practical guidelines how you can deal if you want to investigate a little bit further. That means the statistical community is working strongly in this topic. The other things at the European level, they published their first experimental statistic based on big data and data science. That means machine learning and deep learning algorithm. At the FSO, we did the same. 3 of my colleagues presented in the poster session the result of this pilot project. And at the end, we proposed to the Federal Council in May, so 1 month ago, to create a data science competence center for the public administration. I underline for a public administration, and it has been accepted, and now we are currently writing the concept to start at the 1st January of 2021. Well, I'm finished.
Bertrand, thank you very much for giving us insight what's going on in the statistics area. I'm wondering, just opening this competence center, how far or how close are we in transforming the traditional statistical process? How long will it take to implement that?
It's quite difficult to answer your question. I think the time is maybe not the right the right variable, of course, we need to move forward. But I think the quality and the standards that we are currently applying the statistics have the priority. That means transparency, ethical principle, explainability from our result. That's really the number one, okay? And again, we are working at the public sector and we have to respect these principles. It's quite difficult to answer your question. We will do step by step our experiences, but for sure we will never we will publish our statistic as experimental statistic. The key idea of the experimental statistic is really to say there are experiments, and that means we have the official statistics and we have the experimental statistic. That's really a common approach, I would say, at least in Europe, to gain experience, okay? And in some countries, they started effectively to publish and to rely on that, but we are not so far away currently in Switzerland, clearly not.
I actually like this answer very much because I'm not a big fan of rushing into something, and I also like that you addressed the ethical question, because you were saying that without veracity there's no value in data. And do you think that these official offices could become sort of playing a role in verifying the quality of data and be some sort of certifying office?
That's the question. I think maybe, in order to answer your question properly, I think I'm not sure that one country alone, we need to bring transparency in the whole process. That means, for example, from IoT, we need to be sure that the data that have been collected from a sensor are really stored, not modified along the process, because the added value is really in this approach to really control the entire production process, and not just at the end to say, give me a stempel. And I think even if someone pretends to do that, I think that I am not saying it's not possible, but currently we are not so far. So it needs also resources. We should become, I think the priority from our office is very clear, to produce statistics, and acquiring new role is that's something that needs to be discussed at the federal level and not in our office.
Very good. Thank you very much, Bertrand, for these insights, and
thank you for the invitation.
Yeah. Good luck on your future exploration of this area. Thank you
very much. Bye-bye.